We have the sum from n equals 1 to infinity. 1 plus 1 over n raised to the 2nth power. So this looks familiar. If you recall, the limit as n approaches infinity of 1 plus 1 over n raised to the nth power is equal to e. So if I square this, when I take this and square it, that's the same thing as saying we just multiply the exponents. So it'd be 2n. So this will just be e squared because you're just squaring e. Now, if you want me to show how to do that, let's go through the steps. So the first step is actually rewriting this. So I'm going to write it as e to the natural log of 1 plus 1 over n raised to the nth power. Because if you have some sort of, let's say, x, that's equivalent to e to the ln of x. Okay. So when you do e to the natural log, those cancel and you're just left with x. So I'm not really changing the... This is still equal to 1 plus 1 over n to the nth, so I'm not changing anything. Okay, the next step is to bring down the exponent. So we have n times ln of 1 plus 1 over n. And I'm going to switch the limit and the e. So the limit is going to go on top of the exponent. And I'm going to put n as 1 over 1 over n. Okay, so I forgot the 2 here, so let's bring the 2 as well. And then the 2 could just come outside here. So what I said here is n is equal to 1 over 1 over n. Because now I can use L'Hopital's rule, because as n approaches infinity, you get 0 over 0. So you could just take the derivative of the top and the derivative of the bottom. So the derivative natural log of 1 plus 1 over n is 1 over 1 plus 1 over n times the derivative of 1 plus 1 over n, which is negative 1 over n squared. And the derivative of 1 over n is negative 1 over n squared. A lot of things are going to cancel. And then as n approaches infinity, this goes to 0. So e raised to 2 times limit basically of 1. So that's going to be e squared. Okay, so because the limit is not equal, it doesn't go to 0, we know automatically this diverges by the nth term test.